rather than what is in a smaller. Friction से थोड़ा smaller भी हो रहा है, but it is I said that coalescence, yes or not? लेकिन coalescence होने के लिए particles more. All particles will not coalesce. Why do the particles, water droplets and water droplets will not coalesce together? Coalesce means coming together. Why? What is the reason that if I am taking these two droplets, यदि अब मैं दो droplets को लेकर आऊँगा तो they will not get together. Why? Every water try to maintain their surface tension. Yes or no? सभी water क्या चाहते हैं? Every water droplets they take in a circular area. Why do they take in a circular area? They want to maintain the less surface area. Yes or no? Want to take less. Everyone do not under the surface tension of their own. They don't want to meet with the other. तो लेकिन क्या होना चाहिए? Pressure इतना होना चाहिए कि वो surface tension को तोड़ के they get together. Collision and coalescence. So I said that if an atmosphere where the temperature is more than minus 15 degrees Celsius and water droplets play an what? Significant role to produce precipitation. And larger drops form a large condensation निकले आई. Larger drops का क्या होगा? Condensation निकले आई will be large also. वहाँ पे एक droplet उसके अंदर बहुत सारा बड़ा क्या आ गया? Condensation निकले आई. Form on a large condensation nuclei or through a random collision of droplets. They will keep on colliding. As the droplets fall, larger droplets fall faster than the smaller droplets. ये भी पता है, they will feel, who will feel more gravity? Larger. The larger droplets overtake and collide with the smaller droplets in their path. ध्यान से, the merging of clouds droplet by collision is called as coalescence. But that collision does not always guarantee coalescence. Why? अभी समझा है? Collision does not always guarantee coalescence. Collision से सब मिल जा रहे थे, coalesce हो जा रहे थे, but does not cause. What is the surface tension? What is the reason? Let us see. Main यही आपको लिखना है. This is your collision coalescence theory. Collision coalescence theory. Yes, tell me what is collision coalescence theory? Water droplet, which is I said that temperature is more than minus 15 degrees Celsius. Through the collision, they keep on enlarging. Through the collision, they keep on enlarging, and the larger droplets, by moving downward, it collide with the lakhs of other smaller droplets. And through this coalescence takes place and keep on becoming a large and heavy enough. And then ये heavy enough, such large heavy enough cloud droplets become a part of cloud and then become heavy enough to fall down as a water rainfall. Understood? But it is not necessary that every large water droplets collision with the lakhs of, इसमें से lakhs में से क्या किया? They are collided and coalescence. But some of them, आपको लिखना होगा, some of them will not coalesce. Why? Why? Because of the surface tension of the water droplets. They want to maintain their water surface tension और उस पर प्रेशर उतना नहीं लेगा. Suppose कि ये droplets ऐसे गिर रहा है और ये particles यहाँ पे आ गया, तो उसको प्रेशर भी नहीं लगा कि उसके surface tension को तोड़ दिया जाए. So then it keeps on falling. The sum of the water droplets will collide but not coalesce. Understood? Collision coalesces. अब यही main theory है. That you can see like it is in a water droplet. Large water droplets are it is coming and then smaller water droplets are what is in a capturing around. तो दिख रहा है यहाँ पे ज़्यादा capture हो रहा है. Where there is a more pressure, there is a more capture. There is, it is able to break the surface tension and it become the large. लेकिन जहाँ पर कम होंगे, that area will not be able to put in a water enough pressure to break the surface tension. So it will remain like this. ये दिख रहा है, this area will have accumulation of more. तो ये this is larger water droplets and this region has done smaller water droplets. They started what did collision and coalescence. लेकिन ये नहीं होगा. And I said that in a cloud composed of different size. अब वही चीज को समझा रहा हूँ मैं. Collision coalescence is about to finish. different size droplets. Larger droplets fall faster than the smaller droplets. Although some teeny droplets are swept aside, some collect on the larger droplets forward edge, while the others, I said, capture in the wake of larger droplets and coalescence on the droplets backside. A cloud droplet rising then falling through a warm cumulus cloud can grow by collision and coalescence. समझ में आ गया? Cloud बना, become large, and then it started coming down, and then how it is becoming more and more large? Collision and, तो ये cloud आते जाते रहते हैं जब तक इनको बहुत बड़ा ना बन जाए. Collision and coalescence, and emerge from the cloud as a large raindrop. The cloud's liquid water content, the factors for the cloud formation and raindrop production, the cloud's liquid water content होना चाहिए. Range of droplet size different, that is it should be what is 0.5 micron to the micrometer to the much more larger. The cloud thickness, heaviest precipitation occur in those clouds with the most vertical development. So which can put more gravity? Expanded one or vertical expanded or horizontal expanded? Vertical expansion can move more gravity. The updrafts of the cloud का मतलब समझ रहे हैं? There will be, the air will upthrust it. Yes or not? So that is also their factors. यदि updrafts होता रहेगा, then it will not lead to the what is in a rainfall. Electric charge of the droplets and the electric field in the cloud also. तो वो आपस में पॉजिटिव नेगेटिव का बनाते रहते हैं. It is clear. So what is collision coalescence theory? Tell me first. In a warm cloud composed of only small cloud droplets of uniform size, the droplets are less likely to collide as they fall very slowly at about the same speed. Those droplets that do collide frequently do not coalesce because of the strong surface tension that holds together each other teeny droplets. So why do some clouds are not able to collide and coalesce? Colliding but not coalesce? Because of what? Surface tension. Understood? So what is the collision coalescence theory? Define it. Simple है, आप due to convection there is a cloud formation started taking place. Yeah, due to any kind condensation, cloud formation and droplets of water size forming. Yes, उसके बाद बोलो. अपने कम्युनिकेशन को बढ़ाओ बेटर में, जब बोलो तो बहुत अच्छा बोलो, नहीं तो सामने वाले को समझ में नहीं आएगा तो इंटरव्यू में मार्क्स कम मिल जाएंगे. आई सेड दैट यस टेल मी कोलिजन कोलेशंस. मैं दोबारा बोल रहा हूँ, ध्यान से देखिएगा. आई सेड दैट ड्यूरिंग द वाटर ड्रॉपलेट फॉर्मेशन अंडर इन ए गिवन कंपैटिबल कंडीशन ऑफ क्लाउड कंडेंसेशन न्यूक्लियाई, इसमें भी देख लें क्लाउड कंडेंसेशन न्यूक्लियाई. विच आर द क्लाउड कंडेंसेशन न्यूक्लियाई फॉर वाटर ड्रॉपलेट्स? टेल मी फर्स्ट. Dust particles and salt particles. Dust particles and salt particles, they started condensing during the cloud formation, and one of the water droplets become larger in size beyond their surface as per their maintaining the surface tension, and these large droplets started colliding with the smaller droplets and becoming heavier and greater. They started what? Moving faster downward. And moving downward faster, they put in a pressure and collision with the several lakhs of, यहाँ पे lakhs तो दिखा नहीं सकता, thousands and lakhs of what is in a water droplets. And most of the water droplets under the pressure, they have been able to coalesce. But some droplets are not able to coalesce since their surface tension. Yes? And this way, collision and coalescence at a large scale, it is happening in the upper atmosphere, and cloud becoming heavier and heavier with the different large droplets. and when the cloud become very heavy, they started raining downward. Understood? In the initial, the temperature should be what is warmer than -15, means less than -15. Yes, कौन बताएगा? पहले क्या बोलना है? क्लाउड कैसे बना? Convection led to the cloud formation. Convection led to the droplets of the cloud. Temperature is more than 15 degrees Celsius. Becoming large. Clear है to all of you? It is clear to all of you. What should be the temperature? More than or warmer than? समझ में आ गया? Completely okay. Collision coalescence process. Yes. Next one we are going to see. और ये ज़्यादातर कहाँ पे होगा? In the tropical, subtropical regions में होगा. And at other surfaces are also happening. Next one I said that Bergeron process of ice crystal formation. I said that इसके लिए क्या होना चाहिए? There should be an Bergeron process. So for the Bergeron process and generally in the higher height, for the he said that there should be what is there should be ice crystal as well as there should be super cooled water droplets. It means maybe -5, -10, -15, -20, -25. It can be anything. Understood it? If they are existing like this, now surrounding this there will be water vapor. मुझे बताओ दोनों में ज्यादातर वाटर वेपर किसके पास होगा? Where there will be more water vapor? Near ice crystal or near water droplets? सोच के बताना. कहाँ पे एयर स्पेस कम होगा टू होल्ड द वाटर वेपर? Where the air space will be comparatively less? Water droplets or near ice crystal? वहाँ पे स्पेस कम होगा. ठंडा कौन होगा comparatively? Who will be colder? Ice crystal or water droplet? So where the air will be more contracted. आइस क्रिस्टल के पास एयर मोर कॉन्ट्रैक्शन के फॉर्म में होगा. कैन इट होल्ड मोर वाटर वेपर? कल से समझाते आ रहा हूं, जब एयर कंप्रेस्ड होगा, इट्स ए होल्डिंग कैपेसिटी विल बी व्हाट? लेस. होल्डिंग कैपेसिटी विल बी व्हाट? As much the air will be in contracted form, their holding capacity will be less. तो यहां पे क्या होंगे? Comparatively less. Understood? I said that this environment is already saturated. पहला तो हमने क्या बोला? This is clear. In a saturated environment in the upper atmosphere, the water droplets and an ice crystals are in the equilibrium. They are in the equal in number around. कितने हैं? In equilibrium. I said that they will coexist. Ice crystal and water droplets will coexist and they are in equilibrium. Yes. As the number of molecules leaving the surface of each droplet and ice crystal equals the number of return. Clear? I said that as the number of molecules leaving the surface of each droplets, as the number of molecules, here it is, I said that number of molecules which is leaving the, I said that, and they have some kind of water vapor pressure. यहाँ पे आसपास क्या है? वाटर वेपर है. एंड देन द ग्रेटर नंबर ऑफ वेपर मॉलिक्यूल्स अबव द लिक्विड. क्यों होगा? व्हाई इट विल बी? दोनों आसपास क्या कर रहे हैं? दे हैव सम वाटर वेपर. both have some water vapor space and they are leaving and returning also. If it is leaving 100, they are also taking 100. So equilibrium mein they are maintaining and number of it is also. They are leaving and what? अरे what? Ice water vapor छोड़ता है या नहीं छोड़ता है? Yes or not? इसी वर्ड को केवल मेंशन किया गया है. Ice used to leave water vapor and also it is an accept the water vapor. That is clear. Just एक mention है, but it is not necessary. If you want to write, then you can write. Otherwise, it is not necessary. The major point is over there. The greater number of vapor molecules above the liquid, large number of molecules above the liquid, because it can have a more space.